Did you know that we only use 10% of our brain? I'm gonna stop you right there. We use all parts of our brain. And not only that, but the brain is always functioning, even when you don't realize it. What if I just sit here and I don't move or think of anything? Your brain doesn't just make decisions. Your brain is telling your heart when to beat and telling you when you should take a breath. So if you already know so much about the brain, then what are we doing here? Presley, take it away. Even in the year 2021, scientists are still using the same map of the brain that was invented over a century ago. This diagram divided the brain into different sections like planning things and self-esteem. This is like using a map from the 1700s to travel the globe. So if we know that this diagram isn't accurate, then why don't we just make a new one? Well, scientists are making a new one. It just takes a long time because of how complicated the brain is. The human brain contains 100 billion neurons, making 1,000 connections each. And scientists don't want to just make a diagram, they want to make a full map. This map is called a connectome. There are two types of connectomes. The first is a structural connectome. This one's completely physical. It shows the white matter that connects different parts of the brain. These are called synapses. Think of this one as a road map. The other connectome is the functional connectome. This one's a little bit more complicated. It looks at what different regions of the brain do and what different areas of the brain are communicating to each other. This would mean knowing what someone is thinking and feeling just by looking at their brain map. Connectomes are really hard to make because of the amount of information that has to be collected. There are no existing functional connectomes, and the only existing structural connectome is in a 1 millimeter long transparent worm called the C. elegans. Remember how the human brain has 100 billion neurons? Well, the C. elegans only has 302. So if connectomes are so complicated and hard to make, then what's the point? Well, scientists suspect that neurological issues like epilepsy, autism, and schizophrenia all affect specific neurons in the brain. A connectome would make it possible to pinpoint these neurons and lessen the symptoms or maybe even cure them. There's even hope for diseases like Alzheimer's. The way that Alzheimer's affects the body is by misfolding proteins in the brain, which leads to the gradual shutdown of neurons in all parts of the brain. With a connectome, scientists could stop the spread of the misfolded proteins before the person even begins to show symptoms of the disease. A connectome would also create the possibility of building a supercomputer. Now, obviously, the human brain is more complicated than a computer could ever be. But if you break it down, they aren't that different. A computer functions by using binary code, where it uses two symbols, either a 1 or a 0. A neuron also only has two options. It either fires, 1, or it doesn't, 0. The human connectome has endless possibilities for medicine and technology, which is why it's so important to build the map.